When a metallic block slides past this threaded face, it instantly triggers a reaction down the line. Our goal right now is to take a standard 3-wire NPN normally open proximity sensor and wire it into a fully functional automated trigger circuit. To build this, you need the sensor itself, a 10 to 30 volt DC power supply, a compatible load like a relay or an indicator lamp, and a basic set of wire strippers. If you've dealt with undocumented wiring, you know the frustration of guessing which wire does what. Hooking this up backward can easily short the circuit and ruin the hardware. But once you know exactly where these connections go, you cross the gap between having a simple box of passive electronics and building active, fully automated machinery. Looking at the sensor, we have a single cable containing 3 distinct wires. Before making any cuts, we have to identify exactly what each one does. This diagram shows the universal industrial standard for proximity sensor wiring. Down here in the wire color function table, we can see exactly how the brown, black, and blue wires are assigned. The brown wire is your dedicated positive power intake. It connects directly to the positive terminal of your power supply, handling anywhere from 10 to 30 volts DC. The blue wire serves as the negative supply, or common ground. Step 1 is to strip the insulation back on just the brown and blue wires, then secure them to their respective positive and negative terminals on the DC power supply. At this point, the sensor's internal circuit board has power. It can technically detect targets, but it remains practically useless until we build an output loop to translate that detection into a physical action. That leaves us with the black wire. This is our switching output, but deciding where it connects to our load is where many setups go wrong. Our sensor is labeled NPN. In industrial automation, NPN refers to a syncing circuit. Looking at the schematic for the NPN 3-wire layout, we can see exactly what that means. When the sensor detects a target, it doesn't push positive voltage out. Instead, it acts as a switch, connecting the black output directly to the blue ground. This requires the electrical current to take a very specific path. Positive power flows to the load first, and then it waits. The circuit is only completed when the sensor detects something and provides the ground path through that black wire. This is a critical failure point. If you wire the black wire assuming it's going to supply positive voltage to your lamp or relay, you will end up with a dead circuit, or worse, damaged hardware. Understanding this internal syncing behavior dictates our next step. It feels counterintuitive, but we actually have to wire the load to constant power rather than constant ground. The top wiring layout here actually shows this incorrectly wired to ground. To do this right, we run a wire directly from the positive terminal of the power supply to the positive intake on our load, in this case, an indicator lamp. For the final connection, we take the return side of the load and attach it to the sensor's black output wire. This completes the physical loop. With the wiring secure, we can apply main power to the system and slide a metallic target across the face of the sensor. 2 things will happen simultaneously. The small built-in LED on the back of the sensor body will illuminate, and our external load will trigger, lighting up the indicator lamp. This physical response proves the circuit is sound. The syncing logic is successfully pulling current through the load precisely at the moment of detection. If you test your system and the sensor's internal LED lights up, but the load doesn't trigger, you need to check your components. The most common culprit here is a component mismatch. You might be using a sensor labeled PNP instead of NPN. This diagram shows why that matters. A PNP sensor uses sourcing logic. It pushes positive voltage out of the black wire, meaning your load has to be wired between the black output and the blue ground line, the exact opposite of our NPN setup. Once you have an NPN sensor properly configured, it becomes an incredibly versatile tool. You can deploy this same logic to set up custom 3D printer bed leveling, configure CNC limit switches, or automate parts of an assembly line. Reading a data plate and accurately translating that internal logic into physical wire paths is a critical skill. It's the baseline required for building reliable, automated systems.